Okay, so I just went through your 2 homework assignments that we did from the probability and just kind of randomly handpicked problems that I would put on the test if I was making the test. Because that midterm test that Snow made, that's all they did. They just went through all the homework and handpicked problems that we did and threw them on there. So this is the most recent topic we've studied. Hopefully it's kind of fresh on your mind. A lot of it's new stuff, first time stuff, so it's probably still confusing until the third or fourth time you do it. But let's give it a try. So here we go. A random number generator selects 5 integers from 1 to 70. What's the chance that all 5 numbers chosen are going to fall between 20 and 35 inclusive? So it can land on 20 and it can land on 35. So here we go. There are actually 15 numbers between 20 and 35. So if I just do 35 minus 20, between those two numbers there are 15 numbers, kind of like 1 to 70. Between 1 and 70 there are 69 numbers. But if we are going to include that 35th number, you've got to add 1. So there are 16 numbers between 20 and 35, counting 20 and counting 35. So we know 1 is pretty easy. If I go from 1 to 70, there are 70 numbers, including 1 and including 70. There's 69 numbers between them, but if you're going to include both of them, there's going to be 70 inclusive from 1 to 70. So from 1 it's not bad because we never do any of this business, but if you start on a different number it's kind of tricky. So 20 to 35 including 35, you have to add it in. Alright, so there are 16 numbers that are going to be winners. So this random number generator, push a button on the calculator and it spits out a number. So it can spit out the same number over and over and over again. So we are going to run this machine 5 times. There's going to be 5 events. So you just kind of find the probability of each event and you multiply them. So what are the chances that all 5 events fall between 20 and 35? So there are only 16 winners out of the 70 total numbers to choose from, and that's my chances of winning. 16 out of 70, so it's not great, but if I do it 5 times in a row, that's my first event, times it by your second event, times it by your third event, and so on and so forth, times that by your fourth event, and times it by the 5th event, which is really the same thing as 16 over 70 to the 5th power. Okay, now they're probably going to want you, I don't know how they want you to express your probabilities. Let's see, let's do it real quick. If I go 16 over 70 to the 5th, probably want you to express it as a decimal. So let's see, 16 over 70 raised to the 5th power. It's probably going to be some really small decimal. So it's approximately 0.00062 blah 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 389. So that's the decimal. The percentage, you'd move the decimal over twice, so 0.06% chance. So that's awful. That's way bad. Okay, now the next one. 2-sided dice, one's black and one's white, are going to be thrown. What's the chance that the sum of the 2 dice is a 7 or an 8? Okay, so if you have a dice 1, the black one, has 6 different outcomes. And so does the white one. The white one also has 6 different outcomes. So if I'm throwing them together, I take all of the outcomes of the black, all of the outcomes of the white, and I multiply them together. That will create a total of 36 different outcomes. So there's 36 ways I can arrange these dice. And this one, we can kind of make a picture real quick that's not bad, because I can have a 1 on the black and a 1 on the white, a 1 on the black, a 2 on the white, a 1 on the black, so on and so forth, a 1 and a 4, a 1 and a 5, a 1 and a 6. So there's 6 different ways I can arrange the first dice being a 1. Then there's going to be 6 different ways I can arrange the first dice landing on a 2, and so on and so forth. So 6, 6, 6, 6, 6, 6 times 6, there's going to be 36 different outcomes. What's the chances that the sum of the 2 dice is a 7 or an 8? So here are all the ways to roll a 7. You can roll a 1 and a 6, or the black one can be the 6 and the white one can be the 1. And then you can go 2 and a 5, or you could switch it, 5 and 2. And finally 3 and a 4, or a 4 and a 3. So 7 is actually the most likely number to be rolled when you're rolling 2 die, and it's right in the dead center. So the extremes have the least probability, so like a 1 and a 1 or a 12. There's only one way to roll a 12 out of the 36. There's only one way to roll 2. But the closer you get to the middle, the more outcomes there are. So there are going to be 1, 2, 3, 4, 5, 6. There are 6 different ways to roll a 7 out of the 36 total. Or you win if you can roll an 8. Now here are the ways to roll an 8. A 2 and a 6, or a 6 and a 2, a 3 and a 5, or a 5 and a 3, and the last outcome is a 4 and a 4. And if you switch those, they're still the same, so no switching. So to roll an 8, there are 1, 2, 3, 4. There are 5 different ways out of the 36 different outcomes. So you're just going to roll it once. You win if you can roll a 7 or an 8. So your probability, anytime you have a or, you add the probabilities. So 6 out of 36 plus the 5 different ways to roll an 8 out of the 36. So out of 36 options, I have 11 that are going to win. So 11 out of 36, you can leave them like that. Or if you express it as a decimal, I'm sure you're fine too. Okay, let's move on. So cards. A card is selected at random from a standard deck. Standard deck has 52 cards. It's got 13 clubs, 13 spades, 13 hearts, and 13 diamonds. And the hearts and the diamonds are red, the spades and the clubs are black. Find each probability. If you randomly select a black suit, so there are 26 out of the 52, half of them are black, or a face card, so there's or again. Okay, a face card, the only face cards are jacks, queens, and kings. And there are 3 face cards in each of the 4 suits. So there are going to be 12 face cards. But, just like Brett pointed out, so I'm going to add all my blacks, 26 out of 52, plus all my face cards, which are 12 out of 52. But half of these face cards we've already counted, because we have already counted the black face cards from the clubs and the black face cards from the spades. They are part of this 26, so we cannot double count them. So really, it's 26 out of 52 plus, we're only going to count 6 of the face cards. Then there are the 6 red ones, 3 of the hearts and 3 of the diamonds. So 26 plus 6, 32 out of 52. And I doubt very much that they'd mark you wrong if you don't simplify your fractions. 32 out of 52, you can simplify or express it as a decimal, and I bet you got it right. Okay, randomly selecting a king or a diamond. So there is a king in each of the 4 suits. So there's 4 winners out of the deck of 52. Or a diamond, so I'm going to add all of the diamonds, which there are 13 diamonds out of 52. But actually, we've already counted one of those diamonds. We counted the king, so I need to take him away. There's overlap. He exists in both groups, so don't count him twice. If there's any ever overlap, you've got to subtract it. So it should be 4 out of 52 plus the 12 out of 52. So there's 16 ways to win out of the 52 cards in the deck. Alright. Okay, there's a box. You got 5 kinds of marbles, 7 blue, 5 red, blah 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 blah. You're blindfolded. You are going to pick a marble from the box. So first of all, you got to find how many there are to choose from. So 7 and 3 is 10, 5 and 5 is 10, and an 8. So there are 28 to choose from. Find the chance that you pick a red marble followed by a yellow marble. So there's 2 events. You're drawn twice. So the chances of you reaching in and grabbing a red marble are 5 out of 28. Okay, with replacement and then without replacement. So let's do without replacement. So you're going to pick it out of the bag and you're going to keep it. Now you're going to reach in again and try for a yellow. And so you take your first event and you multiply it by your second event. In your second event, there's 3 yellows. But instead of 28 marbles in the bag, you took one and kept it, so now there are only 27. So whatever 5 28s times 3 27s is. And with replacement, so that means you draw, and then you put it back in the bag. So with replacement, that would be 5 28s multiplied by 3 28, because all 28 marbles are in the bag because you put it back in after you drew. So slightly different. Okay, let's do B. Find the chances that you pick a marble of light color, so either white shade or yellow shade. So let's find, so this one is only 1 event. You're only drawing once. So you win if it's white. And there are 8 whites, so 8 out of the 28 are winners. But so are the yellows, which are 3 out of the 28. So I'm going to take my 8 chances plus my 3 chances, and I have a total of 11 chances out of 28 of winning. Okay, C, this one is an awesome question. It's kind of a logic question. So how many times would you need to draw? So without replacement, so you're keeping them. You're going to draw them and keep them. How many times would you have to reach into that bag and draw marbles to guarantee that you get 2 marbles of the same color. So I could reach in and draw a red, and then my second draw could be a red, and I'm done. That could happen a minimum of 2 draws. But let's find the max, because that's what is going to ensure that we have 2 marbles. Now the maximum is going to happen. So the other extreme, let's say you reach in and draw a color, and every time you draw a different color. So there are 5 colors. So your first draw, let's say, is a blue, then your second draw is a red, then your third draw is a white, then your fourth draw is a yellow, then your fifth draw is a black. Now, at this point, at this extreme, if you draw a different color every time, no matter what happens on the 6th draw, my next draw, I have to double up. So, the max is 6 draws. I am guaranteed on that 6th draw to have at least 2 marbles that are the same color. Okay. Bakery stand has some muffins, 3 chocolate chip, 2 blueberries, and 4 banana nut muffins. So if you buy a muffin at random, so you just choose it at random, what's the chance that you choose a chocolate chip? Or, so we've got a lot of ors going on here. So chocolate chip, so there are 3 plus 2 plus 4. So there are 9 muffins total. The chocolate chips, 3 of the 9 are winners, plus the banana nut muffins. 4 of the 9 are winners. So I'm going to take my 3 winners, my 4 winners. I have 7 chances out of 9 to make that happen. So pretty good odds. If you'd like to buy 2 muffins, and so I guess you can't see them, you're just reaching in a bag and pulling muffins out, kind of like the marbles. What's the chance that the first one that you grab is a blueberry? Okay, that one's 2 out of 9. And the second one is a chocolate chip. So obviously this is without replacement. You're keeping it. You're going to reach in the bag, grab a muffin, 2 out of 9. The next one's going to be chocolate chip. I have 3 chocolate chips left out of only 8 muffins. So I kept that first one. So it is going to be 6 chances out of 72 total chances of winning. So that's not very good. Okay, if you roll a 6-sided die 10 times, so just one die, we're just going to roll, record the number, roll, record the number, roll 10 times. Find the chances that you will roll an even number at least. So I put this on your note card. If at least ever shows up, this is how we're going to do it. We are going to take the chances of it not happening and subtract them from 1. So the chances of something happening versus it not happening are 100%. And it is so much easier to find the chances of it not happening than it is to go through all the scenarios. Because if it's at an even number at least once, so 1 even number wins, 2 even numbers wins, 3 even numbers wins, 4 even numbers win. The minimum number of an even number once wins. So you got to account for everything, which sucks. So here we go. So let's focus on dice. it's 50-50. It's either even or it's odd. So this one's kind of a little different. So the chance of it happening is 3 out of 6, and the chance of it not happening is also 3 out of 6. So the chance of rolling an odd, we're going to go not happening. There are 3 odds out of 6. And we're doing this 10 times. There's 10 events. So 3 out of 6 to the 10th power. And on your calculator, you just type this in. Just type in 1, subtract 3 out of 6 to the 10th power, enter. Whatever that is, that's the answer. It's probably very, very likely. It's really, really good odds that that's going to happen. Okay, let's do B. A 2 at least once. Okay, your chances of rolling a 2 are 1 out of 6. Not a 2 are 5 out of 6. So your chances of rolling not a 2 are much better. So the word at least means I'm going to use the not. So same thing. I'm going to go 5 out of 6 10 times. And then 1 minus that, and that will give me my odds. And I wonder if I wrote them down somewhere. I'm not going to calculate them. But they're both pretty good. I think this was like a almost 100% chance. 0.999. And this one is really good as well. Because if you're rolling it 10 times, chances are every number is going to show up once. And this one was like an 84% chance. Okay, very good. I'd bet money on both those things happening. Okay, let's look at the blood type. The probability that a person in the US has B positive blood type is just a little bit under 10%. So find the chance that a randomly chosen person in the US does not have. So it's going to be 100% minus 9.3%. So the chances of randomly picking some dude off the street is like 90.7%. Okay, that was kind of a logic question, so no fancy formulas there. B, if 5 unrelated people in the US are selected at random, what are the chances that all 5 have B plus? So the first one, you gotta, well, 9.3%. Let's change that to a decimal, 1, 2. The first one, you have a 0.093 chance. Second one, the same. Third, the same. And you times all those events. There are 5 events. So I'm going to times those chances by themselves 5 times. Okay, if 5 unrelated people in the US are selected at random, find the chance that at least one of them has a B positive blood type. So the at least, I'm going to find the chances that they do not. So I'm going to go 1 minus the chances that they do not. The chances that they do not are right here. It is 0.907. And I'm going to do that to the 5th. So whatever that number gives me, this one's actually a higher probability. This is like 39%, 0.386. And this one was way small, 0.000000. 1, 2, 3, 4, 5 zeros. 6, 9, 5, 6. So that's a way small chance. Okay, last one from this section. We're given a two-way table. So kindergartners in a neighborhood elementary school were asked how much they read each day. Here are the results. Got them broke down by gender, boy, girl, and grouped kids that read less than 20, kids that read at least 20. So child, now first, here's what we got to do. We got to total them up. So 27 boys and 18 boys. There's 45 boys in the class, 30 girls, 25 girls. That's 55 girls in the class. So there are a total of 100 kids in that class. Kids that read less than 20 minutes, 27 and 30. 57 kids of the 100 read less than 20. At least 20. We got 43. Alright. So this would be an awesome test question. Okay, A. Find, you're going to select a child at random. Find the chance that that child is a girl and she spends at least 20 minutes every day. So there are my winners. 25 out of 100 are winners. B. Let me erase this. What are the chances that that randomly selected kid is a boy? Or, so my boys are winners, or the child spends less than 20. So here's all my winners, all my boys, those 27 or those 18. Or they spend less than 20 minutes, so either those 27 boys or those 30 girls. Now there's overlap, so visually that's what the overlap looks like. These 27 kids are counted in both groups, so we're only going to count them once. So we're going to go 27 plus 18 plus 30. Cannot count them twice. So that should be 75 kids out of the 100 total. So those are excellent chances that you can pick someone that falls in that category. C. The randomly chosen child is a boy. Given that the randomly selected child is a boy, find the chance that he spends at least 20 minutes reading every day. So this one's worded different than A. Man, I wonder if it's wanting something different. Given that the child is a boy, find the chance that he spends. Okay. I think it is. So given that it is a boy, so we are narrowing the field down. We are only looking at those boys, which there were 45. So it has to be a boy. Find the chance that he spends at least 20 minutes. There are 18 out of those 45 boys that read at least 20 minutes. Okay, D. If you randomly select 4 kids without replacement, so you grab them, set them aside, what's the chance that at least one kid is a girl who reads less than 20 minutes? So less than 20, these guys right here, those are your winners. 30 out of the 100. Okay, so, but because it's at least, I'm not going to focus on the winners. I am going to focus on everyone else. All the boys, or these 25 girls that read at least 20 minutes. So 70 out of 100 are not girls who read less than 20 minutes. So I am choosing 4 kids, so there's 4 events. So I'm going to go 1 minus, okay, this one's going to get, this one is an excellent question. This is very, very good. So it's going to be 1 minus, now I've got 70 chances out of 100. that's my first event, but then I keep that kid out, so now I only have 69 out of 99. Then for my third selection, there's only 68 winners out of 98 kids left. Then there's 67 out of 97 left, and that will tell me what I need to know. Okay, then the factorial business, permutations, combinations. So these, without they're going to show up, that'd be sweet if they did, because they're just calculator. So on your calculator, you got to hit menu, then you got to go into probability, and here's everything. But so the permutations, you've got to type in like 6 and then comma 2, so 6 racers, and you want to know how many ways you can award first and second place. Hit enter. 30. If I want to do 5 factorial, which is just 5 times 4 times 3 times 2 times 1, there we go. Hit enter. Easy. Now, okay, so factorial. Factorial is, I mean, pretty easy to understand. If I have 3 racers and I want to know how many different ways they can finish the race, there's either a first place, a second place, or a third place. So if you got 3 kids running, how many of them could win first place? Any of the 3. But now once someone has won, that only leaves me 2 options for second. Then once someone is locked into first and second, there's only 1 option for third. So 3 factorial is simply multiplying 3 times 2 times 1. So there are 6 ways that you could arrange these 3 kids. So like visually, if you had kid A, kid B, kid C racing, you could go A, B, C, and you could go A, C, B. Then you could go B, A, C, or B, C, A. Then you could go C, A, B, or C, B, A. So there's 6 different ways those kids can finish the race. And that really is the same thing as 3 factorial. And 3 factorial is the exact same thing as 3p3. Permutation. These are the permutations. There are 6 permutations. Alright. So, let's see if we can start playing around with these permutations and combinations. Now the combinations, let's see if I go back. Now these 6 permutations are 1 combination. So I do not care the order. I am just interested in the people specifically. So if you have 3 kids and you want to know how many different ways you can arrange those 3 kids, that is, there's 1 combination. If you had 25 kids and you wanted to arrange them 25 ways, but the combination is, there's only 1 combination. Okay, now let's start. So permutation, order matters. Combination, the position does not matter at all. It's who you are choosing. So this question is an awesome question. Your nephew Ben is on a swim team with 14 other boys. So this is good because you have to use a little logic. There are 15 boys. The coach is trying to select a 4-person team for the upcoming event. So this team of kid A, B, C, D is the exact same team as A, C, B, D. They're the same boys. So those two permutations are different, but the combination is the same. You're using the same 4 kids. So can you help Ben's coach find out how many different teams can he put together? So how many different combinations are there? So there's 14 to choose from. I'm going to do a combination, and I am only going to combine 4 of the 14 kids. So if you punch in 14C4, oh, I guess there's not 14, there's 15. 15 kids. 15 kids to choose from. Combination of 4 kids, and you are going to get 1,365 different combinations. Alright, hold on one sec, let me double check that. So, oh whoops, we're gonna go 15, okay, perfect. Now, how many teams can he put together with Ben on the team? I can't remember what Mindy did, but if we find out how many teams without Ben, so let's say Ben is not there, no Ben exists, so that means there are 14 kids, and we're still going to do how many different combinations can I make out of these 14 kids. So if I go 14 combination 4, there are 1,001 ways I can combine 14 or 4 kids out of 14 to choose from. So if I throw Ben on the team, that adds an extra kid, a 15th kid to choose from. All of these combinations do not have Ben. So all of the difference between these two must have Ben. So there's 1,001 ways that exclude Ben. So if I do 1365 minus 1001, there are 364 teams that include Ben. So what's the chance that that coach draws a number out of a hat and it has Ben's team, a combination of Ben on it? That is 364 teams out of the 1,365 teams. Okay, the scholarship committee is considering 25 applicants for 3 awards. First place you get $3,500, second place you get $3,000, third place you get $2,000, or B, all 3 awards you get $2,000. Okay, this is a good test question because this is explaining the difference between a permutation and a combination perfectly. So this is a permutation and this is a combination. Permutation, the order matters. You would much rather have $3,500. You'd rather finish first than third. This one, you don't care where you are in the top 3 because you all get the same thing. You just get $2,000. So 25 applicants, 3 awards, whatever that spits out. 25 applicants. You're going to choose 3 of them. How many different combinations are there? So this one is like 13,800 and this one is much less. Combinations are always much smaller. Okay, got that done. Next one, the Scrabble question. How many distinguishable permutations can you make out of the following? Okay, so you have all these letters. If you count them up, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there are 12 letters. So it would be 12p 12 or 12 factorial, that's the same thing. But the distinguishable kind of throws it off. That we got to count the doubles. So, oh no, you don't have two S's, you just have one S. Your doubles. So in Scrabble, so if you draw A and you draw A, there's no way to know which A is which. If one was like black and one was red, then you could distinguish. But if you have an A and an A, there's no way to distinguish which one is which. So AA is a double, and LL is a double. And what else is a double? The T's, T and T. Okay, so you have a couple doubles. So you're going to go 12 factorial or 12p12. Then there are two different ways I could arrange these. Like if this was a black and this was a red, I could go black red, or I could go red black. So there are two ways to arrange that. There's two ways to arrange that. There's two ways to arrange that. So I'm going to take all these permutations and I am going to divide by 2 times 2 times 2. I'm going to divide it by each of these doubles. So 12 factorial divided by 8. And there are still going to be a bunch. It's going to be 5,987,520 or 28 or something. Can't read my writing. I think it's 28. Okay, that is similar to kind of this question, C and B. Alright, so furniture delivery truck must include stops at 7 locations, A, B, C, D, F, and G, within the same city. How many different routes are possible? So I got 7 to choose from, and I want all 7. That's the same thing as 7 factorial, which is... Oh man, did I miss the... I missed the question. Okay. Let's see. That is 5,040 different routes. Okay, if a route is randomly selected, find the chance that that delivery will be made in alphabetical order. So of those 5,040 different route options, only one of them is going to be in alphabetical. So 1 out of the 5,040, so that's awful. Probability is awful. Okay, now C, this one is a good question. This one is an awesome question. Okay, if a route is randomly selected, find the chances that the first 3 deliveries will be made to C, D, and G. Okay, so here's the math. The math is, of those 7, it's a combination. So C, D, and G, because it says not particularly in any order, is the same thing as D, G, C. These two are the same. So it's a combination of those 7 stops. I am going to combine only 3 letters. Now, here's the thing. If I do 7 combination 3, that is 35. But 3 letters, that could be A, B, C. Could be A, B, G. I mean, of those 35 options or combinations, only one of the combinations is going to be using those 3 letters that I want. So one chance out of 35 is going to use the letters C and D and G. The rest of those 35 are using like GFE, GFD, GFC, all sorts of stuff. Okay. Oh, this was a good question. How many ways can 6 people, A, B, C, D, E, and F, sit in a row at a town meeting if C and D must sit together? Alright, so here we go. We've got a seat, a seat, a seat, a seat, a seat, and that's it. There are actually only 5 positions. C and D, we're going to marry them and call them one option. So we're going to bind these 2 together. So how many different choices do I have to put in this first seat? I could put A or B, or I could put C, D, or I could put E, or I could put F. There's only 5 choices. Then if I've locked someone in that first seat, there's only 4 choices, then 3 choices, then 2 choices, then 1 choice. So that is 5 factorial. 5 times 4 times 3, there's whatever that is, different arrangements. Now they're going to get actually even higher, because any one of these seats that I locked in C and D, so C and D, there's 2 ways to arrange C and D. I could either arrange C and D, or I could arrange D and C, and that is different. They're different, and no matter where you put them, they're going to change the whole order of everything. So I'm going to take all those arrangements times the 2 ways that I can arrange C and D. So whatever that answer is, that's all your arrangements. Okay, what if A and C and E? So you're going to marry A, C, E. That's 1. Then you can choose B, A, B, C, D, E, F. So now you only have 1, 2, 3, 4 choices. So it's going to be 4 times 3 times 2 times 1. But this choice right here, you can go ACE, you can go AEC, you can go CAE. If you have 3 letters, you are going to times that by 3 factorial, which is 6. There's going to be 6 different ways you can arrange A and C and E. I can go CEA. I can go EACECA. So I'm going to go, the math is 4 factorial, times that by 3 factorial. Okay, the last one. What if A and B are 1, as well as E and F are 1? So A, B, E, F, I've got C and D. So again, I've got 1, 2, 3, 4 choices. So it's going to be 4 factorial. Times that by the different ways you can arrange those. Times that by the different ways you can arrange those. And those are your total arrangements.